Ruth Angelina, a physics education student at the State University of Jakarta. This time we're going to learn about free-falling motion in a vacuum. First, try to answer this question. If two objects with different masses, the feathers and a bowling ball, are dropped from the same height with no initial velocity, which will hit the ground first, and why? You will probably answer the bowling ball because it has more mass. This is the same as Aristotle's statement, which states that in downward motion, an object that has a greater weight will accelerate in proportion to its weight. This is incorrect, but it had motivated Galileo Galilei to test it and ultimately made a more specific and valid statement. Galileo stated that in the absence of air and other resistance, which only works by gravity, all heavy light objects will fall at the constant acceleration. This means that two objects with different masses with no initial velocity that are dropped from the same height will fall at the same time. This is called as free-fall motion. Now, let's watch this video. In this case, the feathers fell into the ground at a slower rate than the bowling ball, not because of its smaller mass, but because the air hindered the motion of the feathers. This is related to the Galileo's theory. Now let's watch the second video. In order to see the true nature of gravity, we have to remove the air. This is the world's biggest vacuum chamber by NASA. Vacuum is a completely empty space without air or the other particles. In this vacuum, both objects will drop with the same height with no velocity, and these amazing things happened. Both objects were in freefall at the same time because there was no other force acting on them except the gravitational force on the Earth. So, the acceleration of the two objects is equal to the acceleration of gravity of the Earth, which is about 9.8 meters per second. So, an object in freefall is not affected by the mass and size of the object, but only by the Earth's gravity. When two objects with different masses are dropped from the same height without initial velocity in the presence of air, then the object with the greater mass will fall first due to air resistance, not because of its mass. But in a state of ignoring air resistance, or in a state in vacuum, both the objects will fall to the ground at the same time and the same acceleration. It is an interesting physical phenomenon, isn't it? And then the calculation of the free-falling motion of object can be calculated by the following formulas. Although a state without air resistance is almost impossible to find on Earth, but in everyday problems, air resistance can be ignored, so that by using the formula for falling objects, we can solve simple problems in everyday life, such as determining the height of a place. Why can't there be a completely empty space on Earth? That's because a vacuum is an absolute vacuum, not because it's a suction, but because it's nearly empty. While it is impossible to create a completely vacuum on Earth, scientists like NASA have been able to create a low-pressure environment called a partial vacuum. And this is the amazing freefall in vacuum.